Thank you for coming back today at our channel, The Physics Mindset, the channel to give you information in electrical installations, electronic repairs, and solar installations. Now, today we are going to look at the hydroelectric power generation. Hydroelectric power generation, remember, is the only substation or the power station we selected from types of the power stations which generate electricity. We decided to discuss about hydroelectricity power because it is the oldest and the most reliable energy, easy to create in every country all over the world. Hydroelectric power is easy in every country. If you're in Africa, you're in Europe, you're in America, Canada, UK, it is very reliable. Okay, now today we are going to discuss, we go into deep, as we promised, we go into deep of the generation of electricity using water. Have you ever imagined how water produce electricity? Oh, the best enemy, water and electricity, they are the best enemies in the world. Now, how comes that water can water can generate electricity? How comes? Only just a simple principle by the force of nature from the water. And this is what we are going to look at, how this water can generate electricity for our homes to light, for our schools to light, for our factories to generate, to operate. How? Check. Let's dip into hydroelectric power generation. If you're an electrician, technician, engineers already in the field, please, knowing this principle, this hydroelectric power generation will help to strengthen your fundamentals in electricity. Okay, now by definition of hydroelectric power generation, we have come up with a definition simple to give us the image of what we are going to talk about. Like, it is the process of producing electricity by converting the energy of flowing or falling water into electrical energy. The energies of the water when it's flowing or when the water is falling, that is the waterfall, that energy which it uses to change that energy into electrical energy. Simple definition: hydroelectric power is the process of producing electricity by converting the energy of flowing or falling water into electrical energy. Now, we know the definition. We want to dig into the real generation of electricity on the dam, that is hydro, using the force of water. The energy of the flowing water, the force of the water. Water has its nature. Water is something which doesn't talk, but sometimes it gives us some sound, some wave sounds. I think it is communicating to us, but that telling us that it is heavy, it is very strong. If you tamper with water, that is God made water something which is very cool. But once you tamper with water, it is when you will understand that water is something difficult, something different. You can't cool it when it gets annoyed. Check the tsunamis. This is the water whereby you can kick with your leg and it splashes away. Now, this is the water, the very water which can break a building of 10 floors, which was constructed by hard metals like Y16, Y12. Okay, steel benders know these types of metal with this type of the beams I'm talking about. A true concrete which is mixed with punk cement, water can break it. That is the worst part when water is annoyed. Now we're going to talk about this water also. We can use this force of water to produce electricity, to run our turbine. Okay? Since it can break buildings which we construct in the towns, like it just sweeps the whole city, that force, that kinetic force, is the force we want to use to generate electricity. Let's dig into the generation of electricity. I have drawn something here as very simple so that we can illustrate the generation of electricity, so that you know before we go after this topic, we shall be going on the transmission, because we have now finished the fundamentals. We have finished this is the fundamentals. This is now the generation of electricity. Remember, we have different types of stations. We picked the hydroelectric power station. So we're going to talk about the hydroelectric power station. This is mainly on the dam. What happens at the dam? The force of water, the force of nature okay? So that we can see how this water is able to give us electricity without cooking it, without burning anything, but its force to give us electricity. Check. Now, we are going to drive our explanation from beginning of the water flow on the river. Okay? Normally, engineers, the moment they saw that, tsunami, it indicates water has that pressure. So, let us look where water flows and it doesn't get dry. Okay? And once water is flowing, water will sweep off the soft rocks, then the hard rocks will remain. That hard rock is where we find a waterfall, because it resisted to being washed away by the water. And that is the hard rock. Water also failed to wash it away. Now, water started washing away other soft rocks. That's when you will find a waterfall, because of that hard rock. Engineers saw some knowledge about it, and they decided to say, let us construct a dam at that hard rock, because once it is hard, meaning it is going to be there forever and ever. Okay? We're going to discuss this diagram until our consumption of power from the generation, from the river to your TV. Let's dig into our diagram to explain the hydroelectric power generation. Please, engineers, students who are doing electrical engineering, this is so essential for you to understand the generation of electricity. Now, we find here, let me use blue so that our diagram looks a bit clear. This is a rock, okay? I think everyone has ever seen a waterfall or a dam somewhere in your country, okay? Now, there is a rock and there is flowing water. I'm going to use blue as a flowing water, okay? Water flowing, this is river, okay? A river comes, it washes away some soft rocks. Now the hard rock remain. This is a dam. Now, this rock, the engineers saw that this is a hard rock, and they decided to construct a dam, very well concrete dam, okay? Helped with the hard metallic instruments. Now this rock holds the river. River flows on the rock, okay? A dam, engineers decide to stop, and they construct this dam. This thing is done inside, down there at the down. Water will flow on top of the turbine. There is a house. We are coming there. Let's go slow. A water flow river. Now let's call this a river. Sorry. We call this a river. River flow. Now, once a river flows, engineers will construct something to collect this river which is flowing. Okay? Now, they call this a reservoir to collect the water, large volume of water, which we are going to turn into a reservoir. Reservoir. Okay, now this is a reservoir. It's like a bucket. Okay, a bucket form, but it is made of a concrete. This is a dam, a constructed dam. When water is flowing, it is collected in the reservoir. Now, on this reservoir, because water will be flowing, coming and going, they decided to create an intake gate. There is a gate to close so that a reservoir can collect this water in big volume. Okay, once this reservoir collects the water, this gate will be closed. Let's say it is closed. Okay, this is the gate. Let's call it an intake gate. Intake gate. This gate, it is the gate which controls the water from the reservoir, which flows into a penstock, so that it reaches the turbine. Okay, we are coming slowly. The water is flowing, then a reservoir holds the water. Now this is our water. A reservoir holds the water. Okay, water is flowing, it's coming. Some water, when the reservoir gets full, some water will flow outside, and the engineers will create a way. Whereby this way we shall call it a Pill's way. A Pill's way, where the excess water from the reservoir will flow and go. Okay, now we have our reservoir full of water. Engineers created a gate where this water can go, can flow, reaching the turbine. Okay, now this intake gate is to control the water which is going to flow from the reservoir. Okay, we are together. Now this water, once they open once, you see when the water is in the reservoir, here we have two kinds of energy, but mainly is the position of the water collected. And there is now, when the water is collected in the reservoir, it is holding a potential energy with it. Okay, a potential energy in this position. Okay, now when the intake gate is opened, this water, the potential energy of the water in one position and in its shape, the potential energy is going to change into kinetic energy. Kinetic energy is the energy of when something is moving. That movement creates that kinetic energy and the force. You see the valley which is the angle. Let me call it the angle. Okay, this angle, it is facing down, meaning there is some gravitation force which will also help to pull that water downwards so that it reaches with high pressure to the turbine. Now, once the gate is opened, the potential energy will change into kinetic energy. Now here we have potential energy, water in position, heavy in large volume. Once we open, kinetic energy will be formed from potential to kinetic energy. Now water will pass here with high pressure in penstock. Now this is a penstock. Let's call this a penstock. Now this penstock, it is where water travel, changing potential energy into kinetic energy with the high pressure, which is helped by the gravity to pull also that water with high pressure. Now the water will knock the moment a turbine is waiting there. Okay, this pressure of the water will knock the blades of the turbine. Okay, these are the blades. 1, 2, 3. Okay, they are like this. When the water pumps here, this will move, and once this one comes, also water pumps, then a turbine start rotating with high speed. Okay, now this water will come and knock this turbine. This turbine will come like this, and this one will also, you see, water flowing. Water will flow also, it knocks this one, this one comes, they knock it. In that interval, in that pressure of the water, turbine will rotate. Our turbine will rotate. Now, the moment the turbine rotates, it doesn't rotate just for fun. It is changing kinetic energy into mechanical energy. Check. In its rotation, in rotating mechanically, it will rotate mechanically. This is a metal rotating by the help of the kinetic energy from the water pressure. Now, water will come here, and in this position, engineers will created a way where this water will pass and go. The moment the water turns the turbine, remember, water continues flowing, okay, and this water will go out. That's the water you see which comes out in the dam. If you have ever experienced the dam, there is this side and there is another side. There is this side which is having high water on the top, and there is another side which is having flow water moving slowly. But the action inside the dam inside, this is the action. The turbine turned, that is turning kinetic energy into mechanical. Now this turbine, it is not only moving alone. This turbine is connected. This turbine is connected on the generator. This is a turbine. Let me write in there. This is a turbine connected on the generator. Now this generator, it's going to turn this mechanical energy. When the turbine is rotating, the generator is going to turn this mechanical energy from the turbine into electrical energy. Okay, you see how we are converting energies from one energy to another, and that is the process of converting energy of flowing water into electrical. Now we are on the generator. The turbine will continue turning. The generators, because inside the generator we have magnets and the coils. Okay, now once a magnet is being disturbed, the magnetic fields is being disturbed by the coil. A coil, there will be an electromagnetic induction. Okay, a process of an electromagnetic induction in the cable, whereby once the magnet has north pole and south pole. Once these magnetic fields being disturbed by a coil, when the turbine is rotating inside the motor, I mean inside the generator, there will be some EMF induced, electromotive force induced in the cable, in the cables of the generator. When the magnetic fields are being disturbed by a cable, there will be an AC induced in the cables. And this is AC is alternative current. Now, when that alternative current is induced in the cable, that is the principle of the Faraday, which states that when magnetic fields are being changed from one position to another with the help of a cable, there will be some electricity in the cable, and that force of electricity is what we call electromotive force, the EMF. Okay, now once the EMF is induced, that in that process, the electromagnetic force and there is some magnet, which we term it into electromagnetic induction. Okay, now this generator will create a three-phase. This generator is a three-phase generator, by the way. There will be a three-phase phase created. This is line 1, phase 1, phase 2, phase 3, a 3 phase. And this power will either be from 10k volts to 30k volts. Okay? Voltage. Now, from the generator, now we have got electricity, by the way. Here at the generator, we have got electricity. From potential energy to kinetic energy, then mechanical energy, then electrical energy. You see? Now, electrical energy, we have got, let's say, 30,000 volts AC 3 phase. Okay? 30,000 volts AC 3 phase. Now, we shall need to transport this power from one place to another. Either you have, this dam is in the center of the country, we shall need to transport this power which is generated, this electricity which is generated from the central to the northern part of the country, to the southern part of the country, or to the eastern part of the country. How? By using a transformer. These transformers are 3-phase transformers. Transformers, we have 2 types of transformers. We have the one which steps up and the one which steps down voltage. The one which steps up voltage is the one we use here at the generation to step up the voltage so that we minimize the cable losses, the power losses in the cable when we are transporting the electricity from one place to another over longer distance. Okay? It is either connected in delta or star delta. Now let us use a delta star. Okay? This is a transformer. Transformer, 3-phase. 3-phase transformer. Okay. Now, this 3-phase transformer, we are going to step up the voltage. This is a step up transformer. We call it a step up. TX present a transformer. A step up transformer. A 3-phase step up transformer. We have a 3-phase voltage which I've got. Now we want to step up so that even though these cables have some resistance, if we step up the voltage to high voltage, extremely high voltage, we shall have some resistance of the cable, meaning some power will be lost, some voltages will be lost, meaning the moment it from the central to eastern part, when power has reduced in the cable, it will not be too much loss of power. That's why we step up. The moment we lose, we shall remain with still high voltages. Not to transport 30k. It will reach where it is now 20k. Now if you step up to 100,000, okay, we shall step up to 100,000. Now this is here, we shall have 100 kV, 100,000 kVA, because generators are measured in kVA. Okay, voltage 1, 3-phase still, voltage 1, voltage 2, voltage 3. This is 3-phase also. Once we say 3-phase, they are phases: 1 phase, 2 phase, 3 phase. Okay, now this transformer, it steps up. After stepping up, now we need to transport this electricity from one area to another all over the country. Okay, now we use these high pylons. These ones, they carry high voltages. I think you have ever seen them. They are very long because these electrical lines have that magnetism, high magnetism. When power is passing through the electrical line, it possesses some electromagnetic, that induction inside it, that force, electromotive force, when it is moving. Okay, now it is either going to eastern part or we take it to the southern part. Now let's say let's take it to the 1000 part. A part of it goes to the 1000 part of it goes to the eastern part, because this is the power generation whereby the country is going to use this power. Our homes, other homes are in the eastern. Now let's say our home is in this side of western. We transport with this pylon, we come, this is high voltage moving, three-phase system moving. Okay, three-phase, live 1, live 2, live 3, three-phase moving. Now three-phase will reach at your village. Now you see how we transmit this power, this electricity. Now at our place we have a local electrical company responsible for distributing our power. Now transmission ends here at the transformer, which we call the sub transformer. This is a main transformer, but we have sub transformers. Now this is a sub transformer, TX, a sub transformer to step down. Remember here we use the step up transformer. Now we are going to use a step down. It has reached power, three-phase system, three-phase power or electricity has reached our villages. Now we want to step down, because if it is 100 kVA, this is too much for our houses. It will burn everything, even our houses. Now we need to step down. Our machines in our houses, they use these TVs, refrigerators, our laptops, our lights, okay, radios, fans, phones, charging of the phones, okay. It uses a 240 volts. Now it means, remember I told you we have two types of transformers, a step up and a step down. A step up is that side. Now at our village we shall have a step down transformer to step down this voltage into the voltage we need to use, stepping down 100,000 volts into a 240 volts, either a 230 volts. It depends on the country you are. Either you're in America, either in the Asian countries, African countries, UK, Canada. It depends where you are. Now the power the poles which you are seeing around your villages, they are from this sub transformer, which steps down the voltages to the voltages you can use. Let us use now another logic behind. From a three-phase connected in delta star, this is a transformer. A star side, on the star side, we are going to have from three-phase, it is going to turn to be a 4-wire. Three-phase wire, three-phase, 3-wire. This is the technical knowledge, technical terms we use. We use a three-phase because they are 1, 2, 3. They are three-phase, 3-wire. Okay? Now, at this side, on the primary side, it is three-phase, 3-wire. On the secondary side, it is going to be three-phase, 4 wires. Okay? Now, where is this 4-wire coming from? Sometimes we can even add to be a three-phase, 5-wire coming from this inside the transformer, stepping down, so that we can use this, whereby we shall have a live 1, live 2, live 3, then a neutral, then an earth. That is a three-phase, 5-wire. Technical terms when you are dealing with transmission lines. Then there is a three-phase, 4-wire. Live 1, live 2, live 3, and neutral without earth. Three-phase, 4-wire. There is a three-phase, 5-wire. Live 1, live 2, live 3, that is three-phase, neutral, and earth. Both are got from this substation. How? By this star delta, the star delta we shall have a phase 1, okay? We have a phase 2, okay? We have A phase is, it is a live, you can call it live 1 or phase 1, live 2, live 3. Now, on this substation in our villages, this coil, the secondary coil, we shall have a neutral from it. Let me put a neutral in black. A neutral from the center of the star. Okay. Now, this is a neutral. This is 3-phase, 4-wire. A neutral, because it has no current, no power in it, we call it a wire. Now, these which have current or power in all voltages, these lines, we call them phase. Now, a 3-phase, 4-wire. We still need the earth. Once you get the neutral on the transformer, it means you have also produced earth also, because they don't have current in it, but they have produced in the middle of the 3-phase system, which the moment we come into transformers, I will explain to you very well about this, how these things, this neutral point is produced on the earth. They are on the one point in the middle of the star. Also here we shall have the earth. And here on the transformer we shall earth this. By that I would use a green so that it appears very well. Good. Okay. Now, even in the middle we have the earth. We shall first earth it here at the transformer. We earth the transformer there. Okay. Now from the transformer we connect it on the pole. Earth, E represent earth. Now here we shall have 1, 2, 3, 4, 5. We have 3-phase, live 1, live 2, live 3. Then we have a neutral wire and the earth wire, meaning we have a 3-phase, 5 wires. That is where you will have some power in your house. Okay, that's why you have some power in your house. They recommend you to earth your house. Okay, why do you earth your house? For protection. Okay, for some protection of the leakage currents. Now, when the electrician does for you electrical, now this is a pole near your house. It has very many wires, live 1, live 2, live 3, 3-phase, then neutral and earth. Some people, they don't earth their houses and they bring earth from the pole. Others only connect live and neutral. You just tap on one live and one neutral. 2 cables, a live and a neutral, without earth. Then you will earth your house. Let us earth our meter box, then you earth it. Okay, it is done by electrician. Then you connect all your wiring inside the house on this earth, which is on the meter box. Okay, meter box is where the meter is going to be placed so that it counts the electricity you're going to use. Okay, now after electrician doing his electrical wiring in the house, you call the authority responsible for distributing power into your houses. Okay, that is the distribution authority, the company responsible in whichever country you are. Okay, like now in Uganda, Kenya, we call it Umeme company. Okay, and he will tap the distribution company will tap only there is live 1, live 2, live 3, neutral and earth. But he will use live 1 and neutral because he has inspected that you have done the earthing, so he will not need to tap his earth. Okay, he will only need either to tap on the live 2 or live 3 or live 1, then he taps on the live one. He connects here the meter, he taps on the meter. Live one comes to your house. Remember, this cable, which we call a solido, has two cables. You will connect also the neutral to come, neutral and live, neutral and live inside your house. Then you have the earth, which is done near your meter box. That's why every house needs to be earthed, so that they don't take time to connect their earth. This earth is a bit strong. Now it is connected. We shall talk, the moment we shall reach on earthing, I will explain to you why we do earthing. And this earthing which you do at your place is very strong, a bit strong. This earthing is connected with the earthing of the transformer down there. Down in the earth, electricity, once you get a short circuit inside your house, this earth, remember, is connected with the live, with the neutral, I mean, here. They work together, but they have different wires. We shall explain this when we come to the transformer. Now, when you get a short circuit, this short circuit will flow in the earth. It goes back to the earth of the transformer. Then it comes back like in a live, that is AC rotating. Okay? Neutral and live, your house will be lighting, and you will be counting. The authority will be counting in the meter box the electricity you use, and you'll enjoy electricity. Check how you have come up with the force of the natural force of water, from the potential energy, kinetic, mechanical, then electrical. You see how water has created our life to be moving, because without water we shall not be having electricity. A lot of areas will not be having electricity just because of this principle of hydroelectric power generation. It carries more gold in our life, because a lot of countries are able to use this type of electricity. All over the country, it was the most popular, the oldest format to create electricity, and it is the easiest to create, because I think some other forms are a bit of expensive, and because they use minerals to create electricity. But this one, we use the natural water, the force of the natural water to create electricity. Every country has water, so it means every country can create electricity using hydroelectric power generation, hydroelectricity using water. Okay, now since you have now seen how electricity is being generated and transmitted, now we have finished the generation of electricity. Now we are going to look at, we need to study a bit of this transmission before distribution. Okay, now we have finished the generation of power of electricity using this one of the power station, hydroelectric power. Now in the next video we are going to look at the transmission of electricity. We start the topic of a transmission of electricity, and you will enjoy how we transmit this electricity, okay, from one place to another. I've just given you a bit of explanation about the transmission because I wanted to complete the generation of power into your house, okay, how it reached your house. And this is a complete set of a dam to your house, to the generation, transmission, then distribution. Okay, let me hope you have gained something from this topic of hydroelectric power, and don't give up to watch it again if you want to know more. The moment you re-watch a video, there is something you're going to miss, but the moment you re-watch, you will learn more, and the moment you watch 3 times, you will learn much. Okay, now don't forget to subscribe, like, and click on the notification bell so that you don't miss on the engineering topics which are coming from our channel, the Physics Mindset. We are always here to provide you with the information in electrical, electronics, and solar. Don't give up. Keep watching. Keep learning. Thank you for watching. See you in the next video on transmission of electricity. That's going to be another new topic. After generation, we transmit this electricity from one place to another. And the topics next, we are going to talk about the transmission of electricity. Thank you for watching. See you in the next video.